Volcanic ash forms montmorillonite due to geothermal heat and pressure in the ocean over several million to several hundred million years. And bentonite is mined as mineral ore containing this montmorillonite. Bentonite is a natural clay mineral with montmorillonite as the primary component. When the montmorillonite contained in bentonite absorbs water, it exhibits the characteristics of swelling and becomes sticky. In addition, bentonite is formed from volcanic ash falling and piling up when a volcano erupted several tens of millions of years ago, and so does not deteriorate over time. Bentonite is a common name for clay containing montmorillonite, and montmorillonite belongs to the smectite group that has a swelling function. Ore mined contains roughly 30 to 40% water. The surface feels moist when touched, and not hard like a rock, but is soft enough that it can be scratched using a fingernail. Our company uses bentonite as a raw material in various products. I will introduce these products. Montmorillonite is extracted from the mined bentonite to produce purified bentonite. This generates the Ben-Gel series. Other products are produced through additional various modifications. Organic modified bentonite for water systems includes Ben-Gel W100, Ben-Gel SH, Ben-Gel W100U, W300U. We also offer the S-Ben Orgonite series for organic solvents. The structure of montmorillonite is a stratified structure, or a sheet structure. The crystal structure of this sheet structure has a thickness of 1 nanometer. It is several hundred nanometers in the lateral direction. The crystal structure is set up like this. The characteristics of montmorillonite are that the crystal layers hold a charge, and that it holds exchangeable cations in order to compensate for this electric charge. The amount of charge held by the crystal is called the crystal exchange capacity. The properties of montmorillonite change drastically depending on differences with the exchangeable cations. For example, if a monovalent cation, lithium or sodium, exists between the layers, water will hydrate around the cations and cause dramatic swelling. In contrast, if divalent cations, calcium or magnesium, exist between the layers, it will demonstrate limited swelling or a small amount of swelling. The swell volume appears smaller in comparison to cations that are monovalent. Montmorillonite swells upon contact with water. In a dehydrated powder state, it is approximately 4 milliliters or 2 grams as shown on the right. However, upon contact with water, it is apparent that the volume grows at or above 10 times as shown on the left. This swelled montmorillonite can be dispersed by shearing, such as by agitation. These scattered particles generate viscosity in the suspension. Furthermore, as the dispersed particles have a negative charge on the surface and a positive charge on the end face, when shearing is stopped, it forms an association structure called a card house structure. Thixotropy is generated in this manner. To illustrate, it becomes watery when shaken and jelly-like when left untouched. Summarizing the characteristics of montmorillonite, its size is 1 nanometer thick plate crystals and are around the same size as carbon nanotubes. The surface area of the plate crystals is around 800 square meters, which is around the same surface area as 3 tennis courts per 1 gram, or 1 teaspoon. Its greatest characteristics are that it demonstrates self-swelling and expresses a reversible viscosity. Furthermore, there are characteristics such as that it has ion exchangeability, has high heat resistance due to being an inorganic mineral, has a high level of safety such that it can be used as a food additive, and has little degradation over time. There are some differences depending on the product. However, the general characteristics of montmorillonite are shown in the following table. We manufacture and sell purified bentonite by extracting montmorillonite as the main component from bentonite extracted from mines. Purified bentonite is classified by its resulting viscosity, color, and cation type. The main products are Bengal, Bengal HV, HVP, Bengal Flake, Bengal FW, Bengal Bright 11K, Bengal Bright 23K, Bengal Bright 25K. Product properties are adjusted to meet the varying fields of use requirements, such as thickeners for water-based paints, pigment anti-settling agent, anti-drip agent, thickener for cosmetics, fat and oil absorbents, clarifying agents for the food industry, additives for building materials, etc. Favorable dispersion is recommended for effective use of purified bentonite. This is an introduction for such a dispersion method. Methods of dispersion include physical dispersion processing and chemical dispersion processing. Physical dispersion processing methods include 1. Raised agitation speed over a long period of time. 2. Raised temperature. 3. Using a high shear disperser. 4. Ultrasonic dispersion. Dispersiveness can be improved by combining these methods. Next is the chemical dispersion processing method, which uses the electrical properties of montmorillonite and includes 1. Addition of anionic surfactants, and 2. Addition of alkaline substances with sodium or lithium. In 1, dispersiveness is improved by using the absorption into the crystallized end face. In 2, the advantages of improvement in the repellent force based on the charge of the crystallized end face from pH and improvement in swelling based on interlayer exchanging with lithium and sodium are used. The main applications of purified bentonite are employing absorbability in applications such as absorbents and clarifying agents for food products, and employing its viscosity properties in applications such as viscosity modifying agents for cosmetics and paints. Applied as an absorbent, for example, It can be used as a clarifying agent to absorb and remove impurities in wines due to the large surface area of bentonite. Applied as a viscosity modifier, for example, it can be used as a viscosity modifier for cosmetics, as an anti-drip agent for water-based paints, and as an anti-settling agent for pigments. Purified bentonite can also be used in mold coating agents, textile-related industries, abrasives, pharmaceutical industries, etc. The purified bentonite recommended for these applications is extracted from mines as bentonite and manufactured and sold by extracting the main component of montmorillonite. Purified bentonite is classified by its resulting viscosity, color, and cation type. The main products are Bengel, Bengel HV, HVP, Bengel Flake, Bengel FW, Bengel Bright 11K, Bengel Bright 23K, Bengel Bright 25K. Product properties are adjusted to meet the varying fields of use requirements, such as thickeners for water-based paints, pigment anti-settling agent, anti-drip agent, thickener for cosmetics, fat and oil absorbents, clarifying agents for the food industry, additives for building materials, etc.